we are going to look how single node work inside the UI. We are going to use this example workflow. It's not exactly one per one because many different models may have a different approach. I was using in 1995-96 in production's for reordering system. At that time, it was only about 100 of these nodes, but it already was a little bit taxing on our system. With better hardware, we can pack them millions and millions inside the one AI model. Let's look closer how the system works. First, we have our constant numbers, and this is just to set our adjusters to the value. For example, our lower is 0 and highest is 100. The adjusters then, based on information on the feedback, it will modify those values, increasing or decreasing. Those adjusters will provide value for our random number generation. You'll notice right here we have it minimum and max. This is set range. And range can be increasing or decreasing depending on what value we provided. We look right here going in a cycle. It can increase if we do some adjustments. And next, it will have it in our gate where we have it minimum and maximum set. This is just a hard-coded for the test. You can imagine this can be any value if you look on a bigger model. For example, cat and dogs. Does it animal reside in this area, or it can be any other flexible number, maybe fit from another node. So it can be stackable as well. For us, this is just what value we expecting when it's come in. And of course, we're using the random number because this is probabilistic model. What is meaning by this? In most LLM models, when you write the word, it's write first word, and second after this, it's look on what most probable word can be after this. And based on this weight, it's put this word. Free LLM model, which does not have any guardrails, you can write 20 times, ask same questions, and you will receive 20 different answers. Well, generally, there will be something about similar, but they will construct a little bit different. It's because the nature of LLM models. And right here, this is a random number, kind of represent this, because even between 30 and 40, we can have it receive 31, 32, all these numbers in this range. This is what affecting probabilistic model. Of course, after we're feeding back, we can see result. It's coming to our gate, which determine if it's a pass or not. And if it's going above value, it will going inside our counter, count, increasing number for the minimum. And of course, if it's going opposite, it will go another count, and it will actually divide, so it is decrease. In this case, you can see how they will go smaller and smaller. So if we're going and we run once, you can see output value is 87. And 87 is above our value, so we're going true. We did increase our counter to 2. From this one, from 100, we subdivide. -2, it will be 87. So right here, you can see it is set our value. And of course, if we run more and more times, depend on what value happened, like again, was above, it's increasing 3. So eventually, it will narrow down. This is not exactly how new training models work, but it is close enough to kind of represent how the training happened. It's going through all these variations between different models and will kind of adjust. Right here, it's just a one single node. And of course, because it's single node, it's much easier to do this. If you look on other nodes like in models, those nodes, they connect between each other. They connect more in a lines and spread and multidimensional. So it's obviously when we train those ones, they require much more effect and balancing required for them to train. It's why sometimes it takes so long time to create a good model. Let's look on a little bit more complex. So right here, this is a simple wave 1 neuron. And if we look down below right here is a little bit another example where we have our image input 16 by 16. And you can see each pixels represent with the value of the gray color. And if we have our dense layer, you can actually see how this layer is representing inside our dense node. You can see how many values we needed to create this model preview. So, and definitely if we have it only one node, it's not bad, but when we have it many, this is take them and combine inside here. By the way, if you're interested, you can also look here on the code and see how the image grid representation work with a specific value. If you're interested in using this program, I will put it link down below. It is called Logic Tensor, I specially built so I can explore and experiment with a logic with a different models to build and will production directly code output in any format as you need it. Link for this will be down below. So let me know what do you think. Let me know if you build any interesting logic and we'll see you next time. Bye.